So now again, as we know, this is the retinol is stored in the liver. So if a cell is required to need the vitamin A or retinol, so what happens when needed vitamin A is released from, one thing more I forgot to mention is that in the form in the liver, it is stored in the form of retinol palmitate. Remember this one. The retinol is stored in the liver in the form of retinol palmitate, because it can be your MCQ's question. So remember this one. If somebody asks you in which form the retinol is stored in the liver, you must say retinol palmitate. But when it is required in target cell, what happens? This vitamin is released from the liver as free retinol. Nothing is attached to it. It's written as free retinol, and again, and you know what, how again free retinol, and again it is converted into the retinol RBP. So what is retinol RBP? RBP means the it's a retinol binding protein, which is a plasma protein. So retinol is transported to the circulation by plasma, the plasma retinol binding protein. If retinol is attached to the RBP, it can be transferred through the plasma. But for the one thing more to add up, because for the mobilization, from liver to, as free retinol, it is believed that zinc plays important role in retinol mobilization. So you have to remember one thing more, that zinc actually helps in retinol mobilization. This could be your MCQs again. Remember this one as well. Again, coming back to the lecture, we got retinol, free retinol from liver, again attaches to the RBP, which is the retinol binding protein, which is a plasma protein, and which is converted into the retinol RBP complex. So the retinol RBP complex binds to specific receptors in the target cell on cell membrane of peripheral tissue and enters the cell. So here the RBP attaches over here to something, and RBP is removed, which is retinol binding protein, and through special receptor retinol enters the cell in the target cell, and from here the retinol is converted into the retinoic acid, and again follows a similar path. But what is important over here, that in the when it binds to the peripheral tissue and enters the cell, many cell actually contains a cellular retinol binding protein. Outside we have got the plasma retinol binding protein, but inside we get the cellular retinol binding protein, which actually carries the retinol to the nucleus. So it is our nucleus. So there we have got nuclear receptor over here. So there is a special protein which is actually called the cellular retinol binding protein, similar to the plasma retinol binding protein, which carries it from near the cell membrane towards the nucleus, and actually it helps in the binding with the chromatin. And again from there it gives information to the DNA, and again these proteins are formed, and again our message is carried out. This is the transportation, and I would rather say absorption, transportation, and storage of vitamin A, and even mobilization we have discussed about here, and how when the vitamin A is required in the target cell, how it actually helps. So this is all the basic concept regarding the basic three concept. And one thing more to add up, this is how in this process we understood that vitamin A, how it works as something similar to the hormones. So this is it for today's lecture on the vitamin A regarding its absorption and transportation and everything. Thank you, and keep visiting Tides Schooling.